Welcome to the second lecture of week 3. This is lecture 3B. We're now going to go away from electrical utility billing and take a look at natural gas billing. As a reminder, the purchase of natural gas basically is in two different forms. I can purchase natural gas by volume, and again, CCF is the most common. That's 100 cubic feet, or larger consumers will have it by MCF, or 1,000 cubic feet. The less common method of purchasing natural gas is by actual energy content, or something called a therm. And remember, a therm is exactly equal to 100,000 BTUs, whereas purchasing it by volume, a CCF is approximately 100,000 BTUs, and an MCF is approximately 1 million BTUs. If we take a look at a natural gas bill, you'll notice a lot of the similar things that we have in an electrical bill. There's actually a customer charge. And you notice if you slide all the way across this bill, in this case it was $20, it's not based on the amount of gas used, just like electricity. This is a flat rate. Just like electricity, then there's a gas distribution charge for the gas used. In this case, this customer used 1,066 CCF, 100 cubic feet. We also have a number of surcharges. We have a gas cost recovery factor, and we have sales tax. So gas is very, very similar to electrical, except that there's not the complexity of two different things that we have to pay for, such as demand versus consumption. In this case, it's simply a product. So again, we have customer charges, we have the charge for the gas, and then we have a number of surcharges, and we have sales tax. Now, it's important to realize when you're looking at a gas utility bill that make sure when you're doing the calculation, especially for EUI, Energy Utilization Index, make sure you use the monthly total of gas usage, because most gas companies will actually put a little historical area down here. And if you read this title, this is average per day. Average per day. This is not a monthly amount. This is an amount per day. So be careful that you use the right quantity when you're doing energy calculations. So we just looked at all the different factors. We pointed them out: customer charge, gas charge, surcharge, cost recovery factor, and sales tax. So that's as complex as a standard gas bill goes. So we can purchase natural gas from our local supplier or local distributor. They are responsible for getting the gas. They store it and they deliver it. So that would be purchasing it all from one supplier. But just like electricity, gas has been deregulated. So natural gas can be purchased from one supplier, called a broker, and then delivered by my local gas company, which is the distribution. This is very typically called brokerage gas. And if this is the case, the customer will end up getting two different bills. Now, there are special rules for deregulated gas purchase. Probably the trickiest one, or the one that has the biggest effect on the customer, is something called the 10% rule. This 10% rule was established by the local gas distributor. The first feature of this is if you decide to go to brokerage gas, in other words, purchase gas from a different source other than your local provider, the local provider will require a long-term contract. Now, this is typically greater than 5 years. What ends up happening then is the customer has to let the local gas company, their local distributor, know how much gas was ordered from the broker for a certain time period. This is so the local provider knows how much gas they have to provide for that will be coming from the broker. Now, if this prediction of what's going to be used during that time period is off, either too much or too little, then there's a penalty. So when I go out and predict my gas usage for my building, let's say for the next month, I have to be accurate within plus or minus 10% of the predicted usage. Now you can see the problem with that. Now, if I predict too little and I'm off by more than 10%, then the local distributor has to add gas of their own. If I overpredict how much I'm going to use by 10%, then the local distributor has to store that excess gas. So in either case, the local distributor is either adding gas of their own or using more storage of their own. And what ends up happening is they charge a penalty for anything in excess of plus or minus 10%. Now, the penalties are huge. The penalties in some cases are up to a factor of 20. So if I'm paying $1 per CCF of gas, that can increase the cost to $20 per CCF for every CCF over or under by 10% of my predicted gas usage. So you have to beware of the 10% rule. Natural gas correction factor. As we mentioned before, a majority of the gas in this country, natural gas, is actually sold by volume. It's not sold by energy content or therm. And gas sold by volume is not an exact energy content because gas varies as it's pulled out of the ground. Now, if a utility company is getting their natural gas from a single source, they typically will put a correction factor on the utility bill. They'll actually say what the energy content per quantity of volume of gas, what it is. Now, in some locations, like in Michigan pulls in natural gas from a lot of different sources and pools it. This pool of natural gas actually balances out, so the energy content does almost come out to exactly 100,000 BTUs per CCF. So this particular distributor in Michigan doesn't have to put a correction factor of the energy content per volume because it's a pooled gas volume from a number of different well sources. So, correction factor for low. A gas company is selling gas by CCF. In this particular case, they're pulling it from a single source. The average BTU would be 100,000 CCF if it was a pooled source, but it's not. So they put a correction factor on the bill of 0.98. So the actual BTU content of the natural gas that they're selling would be 100,000, but only 0.98% of that. So the BTU content is only 98,000 BTUs. That's the value that needs to be used in energy calculations. Note, the utility bill could just say 1 CCF equals 98,000 BTUs. So different utility companies spell out the correction factor in different ways. Now on the flip side of the coin, some gas sources are actually greater than 100,000 CCF, 100,000 BTUs per CCF. So in this case, the correction factor on the bill says 1.04. Again, we take the average value, which is 100,000 BTUs per CCF, times the 1.04. So in this case, the energy content per CCF of this gas is 104,000 BTUs. And that's the value that should be used in the energy calculation. And again, the utility company could just say 1 CCF equals 104,000 BTUs. This ends Lecture 3B, and when you're ready, you can proceed to Lecture 3C. Thank you.